Today we're going to start talking about graphing square root functions, but we're going to do this without using a calculator. So we're going to graph square root functions, and we're not going to use a calculator, and we're going to do this without using a calculator. And we're going to talk about domain and range, and hopefully as we start to go through this, you're going to be able to apply what we learned in graphing quadratics to graphing a square root function. And what I have in terms of the picture here and on your notes is the parent function. It's f of x equals the square root of x. And let's take a look at the pattern in this graph, because if we can learn the pattern, then we should be able to draw the graph eventually. We have a point at 0, 0. We have a point at 1, 1. We have a point at 4, 2, and we have a point at 9, 3. For some of you who are thinking, oh, I'm going to have to memorize all those, I wonder if there's some pattern in there. Like if we look at 1, 1, and maybe it doesn't show up so much on 1, 1, what about 4, 2? What we're doing? We're doing the square root function, and what's the square root of 4? 2. What's the square root of 9? What's the square root of 1? 1. So all that we're doing is we're taking the square root. So now that we know a little bit about the pattern of the function, as we take a look at g of x, we're going to graph this. And before we do, let's try to remember what happens when we add something inside the function. How does that move our graph? So if you think about it, what actually happens is that that's going to move our graph left 3 spaces. It works the opposite way that we think it's going to work. But the minus 2 is outside of the function, and it works the way we think it's going to work. It's going to be down 2. So we're going to take all of our points on our graph here, and we're going to move them left 3 and down 2. So 0, 0 is going to move left 3, down 2. 1, 1 is going to move left 3, down 2. 4, 2 is going to move left 3, down 2. And 9, 3 is going to move left 3, down 2. And remember, when we're working with the transformed function, we're not changing the general shape of the function, we're just moving it around somehow. And once we identify the picture here, we can use the picture to help us come up with the domain and the range. And the first graph that I'm looking at is kind of pinkish reddish in color here. But the domain of that function, domain deals with the x values. And when we look at these x values here, the farthest to the left is going to be the 0. And it's going to be all the different points that are going to go to the right. We don't have any values that are over there that have negatives in there for the parent function. And the range here, what we ask ourselves for the range is, do we have a high point or do we have a low point on the graph? Well, our lowest point is at 0, 0. So our range, which deals with the y values, is going to be greater than or equal to 0. All of our values on that pinkish red graph are above the x-axis. But what it really says is it says, well, find the domain algebraically. And we'll practice that in a couple of moments. But with respect to the domain here, what we can do is we can take this value of x plus 3, which is underneath the radical, sometimes called the radicand. And what we do is we set that greater than or equal to 0. Is how we do it algebraically. Only the value underneath the radical. And we solve this, and our domain is x is greater than or equal to negative 3. If we go back and look at the picture of the graph, what's the value that's farthest to the left in this case? Well, farthest to the left is here at negative 3. Look at the starting point, so to speak, on your graph. Now the range we're going to stick with using our picture to figure it out. The range deals with the y values, and again, we ask ourselves, do we have a high point, do we have a low point in the graph? Well, we're still going to go to the starting point here, which is -3, -2. -2 is our lowest value on our graph, and then everything is above it. So our range is going to be y is greater than or equal to -2. And we'll practice that here in a couple minutes. But the range, we really do look at the picture for now to figure that out. As we look at problem number 2, trying again to get back some of our skills from the graphing quadratics. So we need to remember all of the different transformations. And as what we're doing on this multiple choice question is we want to identify a couple of transformations so we can pick the right answer. Well, what's the first transformation that you maybe see or that stands out to you? Because we have to list both of them anyway. Wasn't the first one I saw, but we'll take it. We reflect over the x-axis. The first value that I see, or the first transformation that I saw, is we went from 0, 0 over here to -4, 0. And what I saw was the left 4. But it doesn't matter. We need both of them. But if we did happen to see the left 4 first, we would be able to find our answer without too much trouble, as long as we know what happens when we're dealing with left 4. And we actually just did an example over here. On number 1, we said that +3 gave us a left 3. So that means it's going to be a plus inside the function. So when we look at our answers, where do we have a +4 inside the function? A, B, C, or D? It's actually at A. The negative outside the function does mean reflect over the x, and I know A and B look very, very similar, so we need to be careful. But the +4 is underneath the radical in A, and the +4 is outside of the radical on B. So on problem B, that would be an up 4 in that case. We just need to be a little bit careful watching our answers. So let's flip over the paper and let's practice the domain a little bit. When we're determining the domain for the square root functions, once again what we do is we look at the value underneath the radical. So in this first one, the value underneath the radical is x plus 2. And we set it greater than or equal to 0. Every single time, it's greater than or equal to 0. And we solve that inequality. We subtract 2 on both sides, and we get x is greater than or equal to -2. Letter B, same kind of thing. We're going to take the value underneath the radical of 3x minus 2 and set it greater than or equal to 0. So 3x minus 2 greater than or equal to 0. And now we're going to move the 2. So add 2 to both sides. And we get 3x is greater than or equal to 2. And then it's 3 times x. The opposite operation is divide both sides by 3. We get x is greater than or equal to 2/3. To find the domain algebraically, we take the value underneath the radical and we set it greater than or equal to 0. So in letter C, 8 minus 2x greater than or equal to 0. I'm going to leave my letter on the left. So we're going to subtract 8 from both sides. We get -2x is greater than or equal to -8. When we divide, because we need to get x by itself, when we divide both sides by -2 in an inequality, because we divided by a -2, because we divided by a negative, the direction of the inequality changes. And in this particular case, we get x is less than or equal to -8 divided by -2, which is +4. one last repetitious time, take the value underneath the radical, only the value underneath the radical, and set it greater than or equal to 0. Solve that inequality. That's how we find the domain. But where we're going to spend the bulk of our time is practicing graphing without a calculator. But in order to graph it, especially without a calculator, we need to be familiar with the transformations. So in this first one, the nice part is that we are given the parent function here, and then we need to identify the transformations. And the first transformation in this particular problem has to do with this 3, which is outside of the function. And what does that 3 do to our function? Well, it was a hard one for people to remember, but it's going to be a vertical stretch by 3. So since it's a vertical stretch, what's going to change in here is going to be the y values of this. But 0, 0 is not going to change because 0 times 3, the y value of 0 times 3 is still 0. But in our parent function, we have this other next point, 1, 1. The y value of 1 is going to be multiplied by 3. So this is going to become 1 times 3. So our second point on this graph is going to be 1, 3. Our next point on our graph is 4, 2. The 2, the y value, is going to be what's going to change next, and it's going to be 2 times 3. Well, 2 times 3 is 6, so our next value is going to be 4, 6. Our next point. And then finally 9, 3. The y value, the 3 is going to change. We're vertically stretching that 3, so it's 3 times 3. So our next value is going to be 9, 9. And here's a picture of just the vertical stretch. But once we identify our vertical stretch, then we also want to deal with minus 4 inside the function. How does that transform our function? Does it go left or does it go right? It goes right. And that's what we need to get back. We were really good at it before, so we just need to remember our different transformations. It goes the opposite direction of what we think it's going to do. So we're going to take this green graph and we're going to move it right forward. So 0, 0 is going to move 4, 0. 1, 3 is going to move to 5, 3. 4, 6. 4, 6 is going to move to 8. Yes, to 8, 6. And then our 9, 9 is not going to fit on the graph because if we add 4 to 9, we get 13. So if you really want it in there, we are going to put it off the graph. But there's our picture. Moving that graph to the right 4 spaces. And after all that, what we want to identify is what's the domain of that pink graph. So we're going to look to the farthest to the left here, which is at 4 here. Its x is greater than or equal to 4. To calculate that algebraically, we would have taken x minus 4 and set it greater than or equal to 0. So look at the picture, figure it out algebraically, whichever way works for you at this point. But once we determine the domain, we do need to look at our picture to determine the range. And we ask ourselves, do we have a high point or do we have a low point on the graph? And it tends to be the starting point. It doesn't tends to be. It is the starting point of our graph, which is at 4, 0. And then all of the points here at 4, 0 are above it. So this is going to be y is greater than or equal to 0. Letter B. H of x equals negative 1/2 times the square root of x plus 6. Again, nice that we are given the picture of the parent function. We have 3 transformations in this particular graph. And the first is that we have a negative outside of the function. How does that transform our function? And reflect over the x. That's what's going to happen with the negative. So we're going to take our parent function, and it's still going to stay at 0, 0. But instead of 1, 1, we're going to graph the point 1, negative 1. Instead of 4, 2, we're going to flip it over the x-axis. So it's going to become 4, negative 2. Instead of 9, 3, we're going to flip it over the x-axis, and it's going to become 9, negative 3. And there's our picture. The next transformation is going to occur with that 1/2, which is outside of the function. And how does that change our function? It's going to be compressing. So we're going to vertically compress by 1/2. Very hard for me to get the points in here. I'll do the best that I can. 0, 0, again, still not going to change because it's going to be the y value that's changing. So 0 times 1/2 is still 0. Our next point on our purple graph here is 1, negative 1. Negative 1 times 1/2 is negative 1/2. So our next point here is 1, negative 1/2. In our purple graph, we have 4, negative 2. Negative 2 times 1/2 is negative 1, so our next point is going to be 4, negative 1. And the last point on our purple graph is 9, negative 3. Negative 3 times 1/2 is 1.5. 9, negative 1.5. And we can kind of see that it's vertically compressed there. We have one more transformation to the graph, and it's the +6 outside of the function. How does that transform our function? Up 6. So 0, 0 now is going to move up 6. And the 1, negative 1/2 is going to move up 6. So it's going to be at 1, 5.5. 4, negative 1 is going to move up 6. So it's going to be at 4, 5. And 9, negative 1.5 is going to move up 6. And we're going to end up at 9, 4.5. Once we get the picture, then we want to determine what's the domain and what's the range. Looking at the green graph in this particular case, our point that's farthest to the left in this case, which also happens to be the starting point of the graph, is at 0. And then all of the values to the right. So this is x is greater than or equal to 0, which is how we would set it up to start for the algebraic way as well. And then at our starting point, the y value of that point is at 6, and all of the rest of the points are underneath that, so our range is going to be y is less than or equal to, not 0, but 6. Let's look at our next graph here, and again, I'm still hoping that the ideas of the transformations are coming back to us. we've got 2 times the square root of negative x minus 2. So we have 3 transformations once again. And our first transformation is the 2. What does that do to our function? It is vertical. Stretch by 2. So we've got our picture of our parent function. So 0, 0 is going to stay the same. But now 1, 1 is going to become 1, 2. Because the y distance of 1 is 1 times 2. And 4, 2 is going to become 4, 2 times 2, which is 4, 4. And 9, 3. 3 times 2 is 6, so this is going to become 9, 6. So here's our first stretch. And what we have is a negative inside the function. How does negative inside the function impact our function? It does. Reflects over the y. So now the 0, 0 is still going to stay the same. But 1, 2 is going to become negative 1, 2. 4, 4 is going to become negative 4, 4. And 9, 6 is going to become negative 9, 6. So there's reflect over the y. Then we have our minus 2. Our minus 2 outside of the function means that we're going to move our graph down 2 spaces. So 0, 0 is going to become 0, negative 2. And negative 1, 2 is going to become negative 1, 0. And negative 4, 4 is going to become negative 4, 2. And negative 9, 6 is going to become negative 9, 4. And now we have the complete graph drawn. And we want to identify the domain and the range. I do want to look at the domain from an algebraic perspective here. What's underneath the radical is a negative x, but it's always greater than or equal to 0. So I just want to take this time to remind you that when we divide both sides by a negative, we divide an inequality by a negative, the direction of the inequality changes. So this would become then x is less than or equal to 0. If we go back and look at the picture, that makes sense, because our starting point here is at 0, negative 2, and then it has all the values to the left. So use the graph or use the algebra to help you figure it out. We do end up with our domain being x is less than or equal to 0. And then our range, well, we have a low point. Our starting point here, 0, negative 2, and all the values are going to be above it. So this is going to be y is greater than or equal to negative 2 for our range. Again, I hope that those transformations are coming back to you. Look in your folder for your transformations chart for a reminder of a couple things. And let's finish by writing a couple of equations based on the transformations. So our parent function y equals the square root of x, and then we've got a reflection over the x-axis, and it's going to go down 7. Well, think about for a minute, where does that negative sign for the reflection over the x-axis go? Does it go inside the function? Does it go outside the function? And hopefully you're thinking outside. So it's going to be y equals negative square root of x. Down 7 is also something that is outside of the function. It's going to be minus 7. Make sure that the minus 7 doesn't look like it's underneath the radical, because it is not. Letter B. Vertical stretch by 3. Up 5, up 2. Well, we just graphed a couple where we had vertical stretch. In fact, the last one that we graphed had a vertical stretch by 2. So that means that it's going to be an outside of the function. Then we've got our square root. It says left 5. And if we go back to the front page of our notes, we did 2 problems with left. That means it's going to be x plus 5. All of that's underneath the radical. And then finally, up 2 is outside of the function, plus 2. And to finish. Vertical compression by 3/4. Well, vertical stretch is outside of the function, so was the vertical compression. We've got our square root here, but it says a reflection over the y-axis. Well, the reflection over the x-axis was outside of the function, which means that the reflection over the y must be inside the function. And there we have our equation.